If you could time travel over 600 million years into the past, you'd land smack dab in the middle of a world filled with strange and fantastic creatures. This was a time when Earth was unrecognizable compared to today. While we often think of dinosaurs as the ultimate rulers of Earth during the Mesozoic era, the truth is that they didn't arrive until about 230 million years ago. Long before the first dinosaurs ever walked the Earth, an astonishing variety of life forms already populated our planet, thriving in strange and often hostile environments. The story of life on Earth began around 3.5 billion years ago with the emergence of simple microorganisms in the oceans. These early life forms, bacteria and archaea, were the pioneers, living in extreme conditions long before the first plants or animals appeared. Fast forward to around 600 million years ago, and we find ourselves in a fascinating era known as the Ediacaran period. This period was home to some of the first multicellular life forms, many of which were so alien-looking that they could easily belong in a science fiction story. During this time, Earth was undergoing dramatic changes in both its climate and its geography. Vast oceans teemed with life, while the land was barren, devoid of the forests, plants, and animals we recognize today. Life was almost entirely aquatic, with soft-bodied organisms flourishing in the shallow seas. These creatures were unlike anything alive today, flat, soft-bodied, and bizarre. While they are difficult to categorize by modern standards, these early organisms played a pivotal role in the development of complex life. But the Ediacaran life forms weren't the only ancient organisms to leave their mark. Just after this period came the Cambrian explosion around 540 million years ago, which is often regarded as the Big Bang of life on Earth. During the Cambrian period, a spectacular burst of evolutionary innovation took place, leading to the rise of almost all modern animal phyla. Trilobites, primitive arthropods, and early mollusks were some of the first creatures to develop hard shells and exoskeletons, giving them a survival advantage in a competitive environment. Predators emerged, forcing animals to evolve in an arms race for survival. The Devonian period, known as the Age of Fishes, came next, around 419 to 359 million years ago. This era saw a remarkable evolution of fish, from jawless species to more complex armored types, and eventually to the first vertebrates with jaws. Meanwhile, on land, the first plants had begun to take root. Primitive ferns and early trees were slowly transforming the once barren landscapes, creating a new environment where future life would flourish. Around this time, animals began to make their first steps onto land. These early amphibians, descendants of lobe-finned fish, crawled out of the water and onto land, marking a turning point in Earth's history. Life was no longer confined to the oceans. The Devonian also set the stage for the Carboniferous period, which followed about 359 million years ago, when lush, swampy forests covered much of the Earth. Giant insects like Meganeura, a dragonfly with a wingspan of nearly 2.5 feet, thrived in these environments, thanks to the high oxygen levels in the atmosphere. However, these early life forms faced numerous challenges. The Earth's climate was anything but stable. Mass extinctions, such as the one that marked the end of the Devonian, wiped out many species. Dramatic shifts in the environment, the rise of new predators, and competition for resources all played a part in shaping the course of life on Earth. Despite these challenges, life persisted, adapting and evolving in response to the planet's ever-changing conditions. The creatures of this time, which lived long before the dinosaurs, were bizarre and magnificent. From massive sea scorpions to early reptiles, the world was full of strange and terrifying creatures that are hard to imagine today. So before the age of the mighty T-Rex, Earth's story was filled with astonishing creatures whose world was as alien as another planet. Join us on a journey through time as we explore the strange and wondrous life forms that existed long before the age of the dinosaurs, creatures that paved the way for the incredible biodiversity we see today. Before we explore these giant flying monsters, the strange sea predators, and the fierce hunters that roamed the Earth before dinosaurs, let's dive into the ocean to discover the planet's first predators. Imagine a world without any major predators. Hard to believe, right? Yet there was a time when Earth's top predator hadn't even evolved. Before lions and bald eagles, before polar bears and great white sharks, before the towering dinosaurs, the oceans were ruled by an unlikely creature that defied modern expectations: Anomalocaris. Existing 500 million years ago during the Cambrian period, Anomalocaris was unlike anything alive today and took on the role of apex predator in a way no other creature had before. This was an Earth in its early stages, completely unrecognizable compared to today. The Cambrian period was a time when the land was pretty much a wasteland, with hardly any vegetation. If there were plants at all, they were likely super simple, maybe something like moss. Life existed primarily in the oceans, and for the first time, these waters were starting to see the rise of complex ecosystems. The seas were filled with all sorts of strange creatures, five-eyed arthropods, clawed worms, and spiny invertebrates that don't really compare to anything we see today. Among these oddities, trilobites were perhaps the most recognizable. These armored creatures crawled along the seafloor, while a tiny worm-like organism called Picaia swam through the water, likely one of the earliest ancestors of fish. And then there was Anomalocaris, the giant of its time. For millions of years, scientists misinterpreted Anomalocaris fossils, and its discovery was as complex as its appearance. Early fossils were frequently misidentified. When scientists first unearthed an Anomalocaris mouth appendage, they mistook it for the body of a shrimp. Another fossil was thought to be a jellyfish. The fossils often turned up together with the shrimp and jellyfish fossils repeatedly found alongside each other, which only added to the confusion. These misidentifications persisted until more Anomalocaris fossils were discovered. With a clearer picture, scientists realized they weren't dealing with a shrimp or a jellyfish, but a creature that looked like something out of science fiction. Anomalocaris was a predator unlike anything that had existed before. Fossils of Anomalocaris have now been found across the globe, from Canada and Morocco to Australia, suggesting it was both widespread and successful. For Cambrian creatures, Anomalocaris was enormous, growing up to 60 centimeters in length, massive in a world dominated by tiny creatures. This alone gave it a significant advantage, but size wasn't its only claim to fame. Anomalocaris was also an evolutionary pioneer, sporting some of the most advanced eyes of its time. These fossilized compound eyes consisted of numerous lenses, much like those of modern insects and crustaceans, giving Anomalocaris an edge in spotting prey. Unlike trilobites, whose vision was limited by mineral-based eyes, Anomalocaris likely had relatively sharp eyesight, similar to the average insect today. It was almost inevitable, then, that Anomalocaris would turn its sights on smaller, shelled creatures like trilobites. Fossils of trilobites show signs of severe trauma, lashes and punctures that match what you might expect from an Anomalocaris attack. Paleontologists suspect that its large, agile body and complex vision made Anomalocaris an efficient hunter, able to detect and pursue smaller, slower animals with ease. At a time when most creatures were vulnerable and relatively unspecialized, Anomalocaris took full advantage, becoming the Cambrian Sea's most fearsome predator. But Anomalocaris wasn't just a predator, it was also part of a broader evolutionary experiment. The Cambrian period was an era of explosive diversification, producing creatures that looked nothing like what would follow. This experimentation didn't last. After mass extinctions, ecosystems often experience a burst of unusual and unique life forms adapting to fill new niches, but many of these species go extinct shortly after, outcompeted by other species that better adapt to their environments. This pattern has repeated several times throughout Earth's history, and the Cambrian is its earliest example. As Earth's earliest known apex predator, it set a precedent for the ecological role top predators would play for millions of years to come. Now that we're leaving the Cambrian period, let's fast forward to the Silurian period and check out the strange-looking creatures that dominated that time. During the Silurian period, the oceans rose high, and shallow seas lapped against the shores of the continents, home to several fascinating creatures. Rugose corals, crinoids, and jawless fish in abundance. Now, in present-day Utah, scientists stumbled upon a chilling scene from the past. One of those jawless fish, named Lecreaspis, met a fate that was both brutal and sadly common. It bore 3 distinct puncture wounds to its head, marks left by the crushing claws of a terrifying predator, the sea scorpion. These ancient sea scorpions ruled the waters during the Silurian period for a whopping 200 million years. They came in all shapes and sizes, from the tiny Alcanopterus, about the size of a paperclip, to the monstrous Jacalopterus, which stretched an incredible 2.5 meters long. That's way larger than the average human. The biggest of the sea scorpions, known as Eurypterids, could reach over 7 feet long, 1,000 times heavier than the largest scorpion you'll find today. And get this, they were not just picky eaters, they often devoured members of their own species, taking down prey that weighed around 180 pounds. What puzzles some researchers is how these fearsome predators managed to crack through the tough armor of their meals. Turns out, a clue lies in the teeth of modern-day scorpions, which contain metals like zinc. Equipped with powerful pincers similar to those of modern horseshoe crabs, they weren't just scavengers. They were skilled hunters, capable of ambushing fish and smaller marine organisms with uncanny precision. Sea scorpions were quite fascinating creatures. Unlike their evolutionary cousins, they kept their book gills, those nifty breathing structures that horseshoe crabs still use today. This meant they were mostly tied to water, but they didn't stop there. They also developed a second respiratory system called Cayman platen, which acted like rudimentary lungs, letting them take short jaunts onto land. Because of this adaptation, some researchers think sea scorpions could even mate and lay their eggs on dry ground, hinting at an amphibious lifestyle. In 2015, paleontologists uncovered the oldest known Eurypterid, Pentacopterus decorohensis, in rocks in Iowa dating back a whopping 467 million years. This ancient beast had compound eyes, a 2-part body, and 6 pairs of appendages. The first pair, right near its mouth, was likely used for feeding, while the other 5 helped it scuttle around. As sea scorpions evolved, those appendages would take center stage, leading to 2 distinct suborders with totally different survival strategies. While these sea monsters were definitely the highlights of the era, things became even more captivating in the Devonian period. The Devonian period had its fair share of sea monsters, but none more formidable than Dunkleosteus terrelli. This massive armored predator was the undisputed king of the seas, a tank on fins that left no creature safe in its path. Dunkleosteus was as dangerous as it was unique, armed with powerful jaws and a bone-crushing bite that would make even the infamous Megalodon seem tame by comparison. In its time, Dunkleosteus ruled, and for good reason. Living about 100 million years before dinosaurs, Dunkleosteus torelli swam through the shallow waters of the Devonian seas. At this point in Earth's history, there weren't any vertebrates on land yet. Everything interesting was happening underwater. The Devonian period is called the Age of Fishes because fish were dominating the seas, diversifying and experimenting with all sorts of weird features, including armor. Dunkleosteus belonged to a group of fish called placoderms, known for their tough, bony plating, and Dunkleosteus was easily the largest of the bunch. It could reach up to 6 meters, about 20 feet long, and weigh in at a massive 1,000 kilograms, about the same as an orca. When fossils of this beast were first discovered in the 1860s, they were found by J. Terrell on the shores of Lake Erie. Terrell was so impressed by the monstrous remains that he nicknamed it the Terrible Fish. Decades later, more fossils were unearthed by paleontologist David Dunkel, and the name Dunkleosteus torelli was coined, immortalizing the creature's terror-inducing presence. This creature had some of the most powerful jaws in the history of fish. Dunkleosteus didn't have teeth in the usual sense. Instead, it had 2 blade-like projections and jawbones that worked like shears, slicing through anything it could fit into its mouth. These bony plates acted as self-sharpening guillotines. Every time it opened and closed its mouth, the edges ground against each other, keeping the jaws razor-sharp and ready for the next meal. Its bite packed a punch, roughly 7,400 newtons of force, enough to snap through bones as if they were crackers. For context, that's almost double the bite force required to break a human femur, the strongest bone in our body. Dunkleosteus' bite could even out-chomp predators like lions and polar bears, putting it in a league with the most fearsome biters in history. The creature's bite was more than just strong. It was fast. Dunkleosteus could open its mouth to a 45-degree angle in a mind-blowing 60 milliseconds, creating a vacuum that would suck in its prey before they even knew what hit them. And this wasn't just any casual snap. At that speed, its prey wouldn't have stood a chance. A human blink, by comparison, takes about 100 milliseconds. So Dunkleosteus's bite was faster than the blink of an eye, literally. Now, you might be wondering how scientists know all this about a creature that's been extinct for over 350 million years. Through a technique called biomechanical modeling, they've been able to reconstruct Dunkleosteus's jaw structure and calculate the muscle force and speed involved in its bite. By analyzing the jaw hinges and the way the muscles are attached, researchers could estimate its jaw speed and strength. As the largest and fastest predator of its time, Dunkleosteus was right at the top of the food chain. It preyed on various creatures including smaller sharks, placoderms, and even other Dunkleosteus. This leads to an interesting idea. Maybe the fierce competition among themselves helped drive their evolution. Interestingly, the biggest threats to Dunkleosteus were actually its own kind. Over its 50 million years of existence, it didn't develop any defenses for the back half of its body, which suggests that this area was rarely targeted in attacks. It seems they often went for the head when fighting each other. It makes sense. Attacking the most vital organs while avoiding bites to its unprotected rear was a smart tactic. Because of this, those Dunkleosteus with stronger armor protecting their heads, fronts, and abdomens had a better chance of survival. We can see this in the robust, tightly fitting armor that evolved over time, which would help them withstand lateral and frontal attacks from their peers. While this is just a hypothesis, It's pretty plausible and recognized by many in the scientific community. When Dunkleosteus died, the armor often scattered and only the front half of its body was preserved. This incomplete fossil record has left us with a bit of a puzzle about what the full creature looked like. But a few exceptional finds have provided clues about its armor arrangement and massive size. Why don't we see anything like Dunkleosteus prowling today's oceans? Unfortunately for it, and fortunately for us, all placoderms, including Dunkleosteus, met a grim fate at the end of the Devonian period. 2 major drops in ocean oxygen levels hit these ancient seas hard, likely wiping out most of the oxygen-dependent placoderms in what's now called the Hangenberg event. This extinction event, possibly linked to a massive increase in UV radiation through a weakened ozone layer, essentially suffocated Dunkleosteus and its kin, leaving an evolutionary gap that other fish groups would later fill. Next up, we will look at the strangest fish in history, a true gem that evolution will forever be grateful for. About 385 million years ago, the land was dry, with just a few patches of plants, fungi, and some tough arthropods hanging on for dear life. But the oceans, they were bursting with life. Squid, bony fish, and fierce sea scorpions were thriving in a water-dominated world. In this lively underwater scene, a small group of fish was gearing up for something big. They were about to take one of the most crucial steps in Earth's history, the leap from water to land. These adventurous fish would eventually become the first vertebrates to walk on dry ground, following in the footsteps of arthropods that had already made the jump. However, this journey wasn't a walk in the park. First, they needed to adapt to breathe air. That's where Tiktaalik comes in, a fascinating fossil that links water-bound fish to the earliest land dwellers. Tiktaalik's standout feature was its fins, which had bones that looked a lot like the basic structure of wrists and elbows. This adaptation allowed Tiktaalik to prop itself up in shallow water and even push a bit out of the water, an important step for moving onto land. It also had strong rib-like bones that helped it support its weight and stabilize itself in shallow areas where regular swimming just wouldn't cut it. While it was still unmistakably a fish, Tiktaalik could move around a bit on land, which probably gave it an edge in the diverse ecosystems of the Devonian period. Another striking feature of Tiktaalik was its head. Unlike most fish, which have their heads fixed to their bodies, Tiktaalik had a mobile neck, allowing it to move its head independently from its body. This feature, uncommon in fish, allowed Tiktaalik to raise its head out of the water to look around, potentially helping it scout for prey and avoid predators. Its skull was flat with eyes positioned on top, similar to modern-day amphibians. This positioning of the eyes and flat skull would have been useful for keeping its body submerged, while still allowing it to see above the waterline, advantageous in the shallow, swampy waters it inhabited. Beyond its fins and head, Tiktaalik had both gills and primitive lungs, a combination that would have allowed it to breathe in and out of the water. While its gills would have functioned much like those of typical fish, its lungs enabled it to survive in oxygen-poor waters or to take in air directly, an ability that would have been beneficial when dealing with low-oxygen environments or making brief excursions onto land. Its feeding habits were likely carnivorous, targeting smaller fish and other aquatic prey. Tiktaalik's large, robust jaws and sharp teeth suggest that it was a predator in its environment, hunting smaller creatures in shallow waters. The discovery of Tiktaalik provided insight into the transition from water to land, as it showed early adaptations necessary for life outside water, even though it was still primarily an aquatic animal. Tiktaalik was about 3 to 9 feet long, making it a relatively large fish of its time. Its discovery offered a glimpse into a stage of evolution where vertebrates began adapting to life on land, laying the groundwork for the evolution of amphibians, reptiles, and mammals. You won't want to miss the terrifying creatures of the Carboniferous period, so let's jump right in. Think about it. There are over 10 quintillion insects in the world right now, and we rarely give them a second thought. Their small size makes them seem insignificant and not much of a threat to us. Imagine a world where insects aren't just annoying, they're predators, and you'd have every reason to fear them. Around 315 million years ago, during the Carboniferous period, these were the days of the giant invertebrates, where insects not only swarmed the Earth, but loomed large enough to make even the boldest humans nervous. Leading this lineup of supersized predators was Meganeura, a creature that has haunted prehistoric landscapes and perhaps our nightmares for millions of years. Meganeura was the largest of its kind, a massive griffinfly that dwarfed today's dragonflies. Thanks to unusually high oxygen levels in the atmosphere at that time, insects and other invertebrates had room to grow to enormous proportions, and Meganeura took full advantage. This dragonfly-like beast boasted a wingspan of over 2 feet, a true aerial horror of the skies. Imagine its powerful wings flapping at a beat of 3 to 8 hertz, much slower than today's dragonflies, but enough to carry its formidable weight through dense air and thick, humid forests. It was more bird than a bug, gliding ominously over ancient landscapes, ready to snatch its next meal from the air or water below. For nearly 6 million years, Meganeura dominated its territory with ferocity, dwarfing every other flying insect in its path. It wielded sharp, spine-covered legs and huge, serrated mandibles that allowed it to catch and crush prey in its grip. Those spiny legs were as much tools for capturing prey as they were weapons, each strike designed to immobilize and terrorize. And its massive eyes were specially evolved to locate even the smallest movements, ensuring that no insect or amphibian within range escaped its gaze. The discovery of Meganeura's fossilized remains in France in the 1880s revealed an entire class of ancient dragonflies with similar features. Among these, Meganeuropsis permiana pushed the boundaries of what we consider an insect. Unlike the lightweight wings of modern dragonflies, Meganeura's wings were reinforced with a dense network of veins and braces, allowing it to carry significant weight in flight. Yet despite its imposing size, Meganeura didn't have great speed. Unlike today's dragonflies that dart around at blinding speeds, Meganeura moved with a slow, sinister precision, gliding through the swamps and forests in a way that made it more akin to a bird of prey than a bug. Its flight was all about endurance and power, not agility. In its larval stage, Meganeura was an underwater terror, lurking in rivers and lakes as a juvenile predator. Fish and aquatic insects were its early prey, ambushed with a speed that belied its later sluggishness in the air. But once it grew into adulthood, Meganeura left the water behind, transforming into a forest-dwelling hunter that patrolled the swamps for any creature small enough to devour. Its hunting strategy was brutal: locate, lock on, and dive with terrifying accuracy, seizing its prey mid-air or on the forest floor, then using its mandibles to rip into flesh. Meganeura wasn't just a big bug. It was one hell of a scary predator. If you are a huge fan of the prehistoric era, you are probably familiar with the legendary Dimetrodon. This captivating creature, which dominated the Earth before the dawn of dinosaurs, has earned its reputation as the iconic symbol of the Paleozoic era. This era, which ended 252 million years ago, was a time before flowers, birds, mammals, and even crocodiles. Dimetrodon, with its lizard-like appearance and distinctive sail on its back, was one of the most unique creatures of the Permian period, the last era of the Paleozoic. Dimetrodon's most striking feature is its diverse set of teeth. Its name, which means two-measure tooth, reflects the fact that its kin had differently shaped teeth for various purposes, unlike most animals of that time. It had long, fang-like teeth for capturing prey, along with distinct incisors and backward-facing teeth ideal for tearing through flesh. In its role as an apex predator, Dimetrodon showcased a powerful bite. Species within the genus typically ranged from 1.7 to 4.6 meters in length and weighed between 28 and 250 kilograms. The largest known species, Dimetrodon angelensis, could weigh up to 250 kilograms, 550 pounds, a size comparable to modern lions and some of the largest tigers. However, many Dimetrodon species were considerably smaller. The tiniest, Dimetrodon teutonis, measured just 60 centimeters, about the size of a house cat. The skull of Dimetrodon is particularly intriguing, being tall and laterally compressed, with high-set eye sockets and large infratemporal fenestrae located behind each eye. The upper jaw tip is raised to align with the lower jaw's tip, an adaptation usually found in animals that prey on slippery fish. This suggests that Dimetrodon might have had a diet that included more aquatic animals than terrestrial herbivores. Fossil sites revealing 39 Dimetrodon specimens also contain the remains of 88 Diplocaulus, a small boomerang-headed amphibian about a foot long, indicating that Dimetrodon specialized in catching slippery prey. Fossilized tracks discovered in Oklahoma further suggest that Dimetrodon was capable of a unique walking style referred to as a high walk. In this posture, its belly and much of its tail would have been elevated off the ground, allowing its legs to be held partially straight, offering a balance between lizard and mammal movement. This posture made Dimetrodon more agile compared to the sprawling movements of amphibians. As for its sail, scientists once believed it served as a temperature regulator, absorbing sunlight for warmth and releasing it when necessary. However, a 2010 study revealed that juvenile Dimetrodon had disproportionately large sails, suggesting that the sail might have been used for communication instead. Similar to modern mammals, which often possess eye-catching features to attract mates or assert dominance, Dimetrodon's sail may have played a crucial role in social interactions. With its diverse teeth, exceptional speed, and intricate social behaviors, Dimetrodon was a dominant presence in early Permian environments. Its adaptability allowed it to thrive in various habitats, from swamps to deserts, across regions from Canada to Texas and even Germany. Unfortunately, Dimetrodon's reign ended around 270 million years ago. Shortly after, the Great Dying, an environmental catastrophe, decimated nearly all stem mammals. Yet thanks to its adaptability, some descendants of Dimetrodon survived and diversified over the subsequent 20 million years, evolving into a range of forms, from small burrowers to mighty saber-toothed giants. Now let's talk about a fascinating herbivore that's millions of years older than dinosaurs, one you probably haven't heard of. Lalieudorhynchus was a strange-looking creature from the Permian period, and it might just be the ancient equivalent of a hippo. Despite its reptilian appearance, this creature, Lalieudorhynchus, is actually a synapsid, making it a distant cousin to mammals. While Lalieudorhynchus may not ring a bell, its more famous relatives like Cotylohynchus certainly do. These cassids are notorious for their massive bodies and disproportionately small heads. Lalieudorhynchus is the last of the cassids, possibly signaling the end of the pelycosaurs, a group that dominated earlier in the Permian but gradually declined as more advanced therapsids, such as gorgonopsids and dinocephalians, emerged. Lalieudorhynchus walked the Earth around 264 million years ago. For years, scientists believed that a group of synapsids known as varanipids managed to outlive the pelycosaurs. But recent research has cast doubt on that, suggesting that these creatures may actually be reptiles. The only known skeleton of Lalieudorhynchus was excavated from the Lalieud Formation in France, lending part of its name. The rhynchus means nose, even though we still haven't found the skull. This odd naming convention comes from its connection to Cotylohynchus. It's thought that this creature measured around 3.75 meters long, and its bones suggest it was a subadult. From what we understand, Lalieudorhynchus had a body structure similar to others. They had massive rib cages, likely designed to handle huge quantities of low-quality plant matter. Those sturdy limbs may have been used for fighting off predators or digging for roots. Most of its skeleton in the fossil found were missing, including the skull. But if it resembled its relatives, it probably had a tiny head, a feature that complicates our understanding of its survival strategies. This bizarre structure could have made foraging a serious challenge for such a large creature. While cassids have long been considered terrestrial animals, some paleontologists are beginning to think that they might have been semi-aquatic. Lalieudorhynchus has the strongest evidence for this theory. Its bones lack growth rings and are spongy, traits often found in aquatic animals. Foraging on land would have been a daunting task for these creatures, especially given their short necks and limited range of movement. They may have needed to wade into the water just to get a drink. In contrast, foraging in water could have been less taxing and offered a richer food supply. This creature was heavily reliant on its environment to stay warm, vulnerable enough to overheat if it couldn't find cool water. While it likely grazed on aquatic plants, it may have needed to come ashore to bask in the sun. Yet, as the world around it changed, Lalieudorhynchus might have developed a hippo-like strategy in reverse, feeding on land during the day while retreating to the safety of the water at night. Lalieudorhynchus was probably a bit too self-conscious. Now let's shift our focus to the big bad land predators. Over 260 million years ago, long before dinosaurs stalked the Earth, a nightmare scavenged the ancient landscapes of the Permian period. It wasn't a reptile, nor was it a mammal. This was the Gorgonopsid, a creature so terrifying that its name was inspired by the monstrous Gorgons of Greek mythology. Armed with saber-like teeth and a relentless drive to hunt, Gorgonopsids struck fear into anything unfortunate enough to cross their path. These apex predators rose to dominance after a catastrophic extinction event wiped out the formal ruler of the Earth, the Dinocephalians, clearing the stage for the Gorgonopsids to unleash their fury. When paleontologists first unearthed the remains of these beasts in 1876, they were met with chilling skeletal features. Elongated knife-like teeth set into narrow, rigid skulls. These teeth could shred through flesh with terrifying ease, making the Gorgonopsids among the earliest saber-toothed predators in history. They weren't cats or mammals like the later Smilodon, nor were they reptiles. Instead, they were therapsids, a group that had branched off from early reptiles and would later evolve into mammals. But Gorgonopsids, with their deadly fangs and ferocious instincts, were nothing like the mammals we know today. Gorgonopsids were remarkably advanced for their time, exhibiting a blend of both primitive and modern mammal characteristics that gave them a unique yet familiar look. Imagine a cross between a leopard and a monitor lizard. They had an array of differently shaped teeth for different tasks, much like mammals, but they could replace broken teeth throughout their lives, just like reptiles. Their hind limbs were right under them, similar to mammals, while their forelimbs sprawled out to the sides, like reptiles. Gorgonopsids first appeared around 265 million years ago, initially quite small, no larger than a human foot. In these early stages, they could only prey on small reptiles, lurking in the shadows of more powerful predators. But over time, each new genus grew larger and deadlier. The extinction of the Dinocephalians gave them a rare opportunity to ascend, and the Gorgonopsids seized it with ruthless determination. As the Permian era neared its end, one genus of Gorgonopsids stood out as the most fearsome of all: Inostrancevia. Imagine a creature as long as a grizzly bear and just as muscular, weighing over 1,000 pounds. Inostrancevia was the top predator of the late Permian, equipped with limbs that combined durability with speed. It hunts by outrunning and overpowering herbivores, its 6-inch-long canines capable of tearing through flesh and organs alike. Some believe it may have attacked with precision, going straight for the throat like the Smilodon. Others think it used a more drawn-out method, wounding its prey and letting blood loss and shock take their toll. Either way, for creatures of the Permian, an encounter with Inostrancevia often meant a slow and agonizing end. Inostrancevia's hunting grounds spread far, reaching from what is now Africa to parts of Asia and even European Russia. The variety of environments it adapted to is astonishing, from the warm, lush floodplains of South Africa to the freezing deserts of Russia, where it may have developed fur to survive the cold. Though the existence of fur on these beasts is still unconfirmed, one thing is clear. Inostrancevia was a versatile, cunning predator, but even creatures like these couldn't escape the inevitable. Inostrancevia, alongside other Gorgonopsids, faded into oblivion, leaving only bones as evidence of their reign. Yet for millions of years, they were the ultimate nightmare, creatures crafted by evolution to instill fear, spill blood, and rule the ancient world. As we mentioned earlier, Gorgonopsids were true terrors across numerous ecosystems worldwide during the Permian period. This is a big deal because if you could take a time machine and go back to the middle or late Permian era, you probably wouldn't survive a month, regardless of how good you were at blending in. But one particular area on the map would be exceptionally life-threatening: South Africa. South Africa was home to some of the deadliest Gorgonopsids, members of a distinct subfamily known as Rubidgeinae. While the notorious Inostrancevia might have been the largest individual Gorgonopsid, the Rubidgeinae were fierce and, on average, much stockier and heavily built. These creatures evolved to possess terrifying features: robust, deep-set skulls, serrated teeth, and a notable lack of a parasphenoid bone, which meant their skulls were reinforced and specialized for tearing flesh. And their teeth? They were built not only to pierce, but to slice through tough hide with a level of efficiency that made them even deadlier than the infamous Inostrancevia. One of the largest Rubidgeinae, Rubidgea atrox, was a monstrous predator discovered on a farm near New Bethesda in the 1930s. With a body size reaching up to 10 feet or 3 meters in length, this predator's sheer bulk made it a dominating force. But it was the skull that took this beast from frightening to nightmarish. Rubidgea's skull made up over 15% of its body length, and it wasn't just big. It was heavily fortified with thick, bony protuberances known as skull bosses, indicating it was built for brutal close-quarters combat with large prey. Despite its massive size and fearsome teeth, the Rubidgeinae didn't possess an overly powerful bite. Reconstructions suggest its bite force was around 715 newtons, only marginally stronger than that of a modern wolf. But don't let that deceive you. Its saber-like canines were exceptionally efficient, capable of slicing through flesh and armor-like scales with terrifying ease. This was a hunter designed by evolution to bring down prey with precision, and its very presence could alter entire ecosystems. And as if facing down one Rubidgeinae weren't bad enough, evidence suggests they often lived in groups. This subfamily's members may have shared the same habitats, hunting grounds, and prey. South Africa during the late Permian wasn't just dangerous, it was an ancient nightmare brought to life. But there is more. Long before the age of dinosaurs, the Permian period was ruled by some of the most extraordinary creatures that walked the earth. Surprisingly, it wasn't reptiles that held sway as the top land predators. This role belonged to a group of animal ancestors known as synapsids. These powerful, often strange-looking creatures were the ancestors of today's mammals, and some were as terrifying as any dinosaur. One of the most notable and mysterious of these predators was Gorynychus, a fearsome creature with dagger-like teeth and a bone-crushing bite that has fascinated paleontologists for years. Unlike the sail-backed Dimetrodon, which often gets the spotlight when we talk about the Permian, Gorynychus remains a lesser-known terror. But don't let its obscurity fool you. Gorynychus was no small fry. With a jaw structure built to withstand incredible forces, Gorynychus preyed on other creatures of the time, including armored herbivores and even other predators. And it wasn't alone. The Permian landscape also hosted other impressive predators, like the Gorgonopsians with their wolf-like builds and saber teeth. Yet, Gorynychus stood out, partly because of its anatomy and partly due to its unique evolutionary story. Unlike the more famous Gorgonopsians, Gorynychus belonged to a different branch on the synapsid family tree, the Pterosaur. Known for wide, robust skulls and formidable teeth, Pterosaur like Gorynychus were closely related to cynodonts, the ancestors of true mammals. Its unique skull shape and tooth structure place Gorynychus in a special category. This animal was built not only to hunt, but also to crush bones, making it one of the earliest land animals to access the nutrient-rich marrow inside prey. This bone-crunching behavior is something modern predators like hyenas use to great advantage, and Gorynychus seems to have pioneered it millions of years before. Named after the three-headed dragon Zmei Gorynych from Slavic folklore, Gorynychus was first discovered in Russia. Its name is a nod to both the creature's fierceness and its Russian origins. The primary species, Gorynychus masutinae, was named after Olga Masutina, the researcher who meticulously prepared the fossil specimen. The most complete Gorynychus masutinae fossil suggests that this species was about the size of a wolf, while the skull of Gorynychus sundirensis indicates it may have been closer to bear-sized. In fact, their skulls alone offer a fascinating glimpse into Permian ecology. The skulls, while similar to Gorgonopsians in general shape, were notably wider, which gave them a different set of advantages. The triangular skull of Gorynychus allowed for both power and precision, with a narrower snout but large, saber-like fangs. These fangs weren't just for show. Unlike modern predators, Gorynychus had two sets of fangs at times, with replacement teeth growing right behind the originals, ensuring that it always had a fresh pair ready for action. Interestingly, Gorynychus sundirensis's teeth show signs of extensive wear, suggesting that it regularly chewed through tough materials, perhaps bones, to reach the marrow. Evidence from the Sundia 1 fossil site in Russia backs this up. The site contains bones with bite marks that align perfectly with the powerful jaws of Gorynychus. It's believed that, like modern bears, this species actively sought out nutrient-dense marrow, which would have given it a serious advantage in the harsh Permian landscape. The evolution of Gorynychus offers more than a simple predator-prey story. It demonstrates the adaptability of top predators. For a long time, scientists believed that large carnivores were too specialized to switch ecological roles easily. Gorynychus challenges this notion. Though it had a powerful build for predation, its relatives in the Therocephalia group spanned a range of niches, from insect eaters to herbivores, suggesting an underlying flexibility. This adaptability was not exclusive to Therocephalians either. Archosaurs, the ancestors of both crocodiles and dinosaurs, similarly descended from large, powerful predators. The existence of Gorynychus reveals that evolution allows even specialized predators to be surprisingly adaptable when ecological pressures shift. Though it may lack the fame of its dinosaur successors, Gorynychus was a predator of legend in its own right, embodying a rare adaptability that helped shape the animal kingdom. Finally, let's take a look at a prehistoric creature that existed before dinosaurs and was still around when they finally showed up. What do you get when you cross a prehistoric hippo, a sumo wrestler, and a cow? Possibly Moschops. This strange beast was a massive calf-faced herbivore that roamed the Earth about 265 million years ago. Named by the paleontologist Robert Broom in 1911, Moschops earned its name due to its unique, cow-like head shape. Despite its appearance, Moschops wasn't a cow or a dinosaur. It was a therapsid, an early relative of mammals that thrived during the Guadalupian epoch. This creature was designed to survive in an ancient, swampy world. At 8.9 feet long and equipped with dense limbs and a massive, thick skull, it was among the largest herbivores of its time. Only Dunkleosteus, another hefty Permian herbivore, could rival its size, reaching up to 16 feet. But size alone wasn't what made Moschops famous. It was the creature's incredible skull. The skull's upper bone was nearly 4 inches thick, making it one of the densest in the animal kingdom. This unique build likely protected it during dominance contests, a form of headbutting where two Moschops would approach each other and push, using their thick skulls to establish social hierarchy. Their bodies were built like wrestlers, with strong forelimbs holding much of their weight, giving them a giraffe-like, sloping back. This shape wasn't just for show, it made them tough contenders in a slow-motion, prehistoric version of a wrestling match. Yet, with their heavyweight bodies and relatively short legs, Moschops wasn't winning any races. Running wasn't their style. They were heavy-footed, powerfully built herbivores that relied more on their bulk than speed. Moschops' distinct appearance extended to its feeding habits. Its jaws were lined with chisel-like teeth, perfect for slicing through thick vegetation, likely the tough stems of ancient plants like cycads. With little nutrient value in their food, they may have spent hours grazing to fuel their enormous bodies. The structure of their jaw and neck muscles hints at a herbivore that needed considerable effort to chew through its low-quality, fibrous diet. These creatures might have lived in small herds, where social dynamics and headbutting were likely routine parts of life. The herd setup would also offer protection against predators, although few could take down fully grown Moschops. Predators like titanosuchids or therocephalians were probably more inclined to target the young or weak, leaving the adults relatively safe. What's fascinating is that Moschops' design suggests it may have spent time in water. Similar to hippos, their short limbs and bulky bodies could have lent themselves well to a semi-aquatic life. Living partly in water would help support their weight and protect them from some terrestrial predators. Moschops remains were first uncovered in South Africa's Karoo region, specifically in the Tapinocephalus assemblage zone, a site packed with unique prehistoric finds. Although not widely known today, Moschops hold an important place in evolutionary history. Imagine a world 200 million years ago, when the skies were not yet dominated by birds or bats, but instead by an extraordinary group of reptiles known as pterosaurs. Among them was Dimorphodon, one of the first large animals to master the art of flight. This remarkable creature belonged to a category of winged reptiles that paved the way for the evolution of flight, showcasing some of the earliest adaptations to life in the air. Dimorphodon was relatively small compared to later pterosaurs, boasting a wingspan of about 1.5 meters. However, its size did not detract from its significance in the evolutionary narrative. Its name, meaning two-formed tooth, reflects its unique dentition that hints at a diverse diet, suggesting that it fed on a variety of small animals, likely including fish and insects. In the early Jurassic period, the world was a vastly different place. While the land might have been largely barren, Dimorphodon thrived in a landscape that was probably dotted with primitive trees and vegetation. Paleontologists theorize that this creature may have descended from a gliding ancestor, similar to modern-day flying lizards like the Draco. This early ancestor likely had wings made of skin, extending from its fingers down to its ankles, enabling it to glide through the forests. Over time, as the need for powered flight arose, pterosaurs like Dimorphodon evolved larger wings, featuring a dramatically elongated fourth finger that supported the wing membrane. The construction of its wings was a marvel of evolutionary engineering. The wing membranes of Dimorphodon were not only vast, but also reinforced with thin rods of stiffer tissue. This structure allowed for better aerodynamic performance. Muscle fibers within the wing membranes allowed Dimorphodon to modify its contours as it flew, a feature that contributed to its agility and maneuverability in the air. The design of its wings is very unique. When examined in cross-section, the wings reveal a shape known as an airfoil, characterized by a rounded front edge and a sharper back edge. This aerodynamic shape allowed air to flow faster over the top of the wing than beneath it, creating a pressure difference that effectively lifted Dimorphodon into the sky. The larger the surface area of the wing, the greater lift it could produce, indicating that Dimorphodon was well adapted for flight. Dimorphodon fed on a great variety of insects, which had already begun to take to the skies during the Jurassic period. Its fossils suggest that Dimorphodon was not just a skilled flyer, but also an adept hunter. The variety of its teeth indicates a flexible diet, allowing it to capitalize on available food sources. The sharp, pointed teeth were likely well suited for catching fish, while broader, flatter teeth could crush the shells of crustaceans. This adaptability was crucial in the dynamic ecosystems of the time, where food sources could vary greatly based on environmental changes. Dimorphodon is often depicted as a forest dweller, navigating through the canopy in search of prey. The combination of its flight capabilities and its dental adaptations paints a picture of a creature perfectly suited to its environment. The adaptations seen in Dimorphodon laid the groundwork for the incredible diversity of flying reptiles that would follow, ultimately influencing the evolution of birds. Fossil discoveries of Dimorphodon have been widespread, found in locations ranging from England to the western United States. This geographical distribution indicates that it was a successful species, able to thrive in a variety of habitats. The discovery of numerous well-preserved fossils has allowed paleontologists to glean insights into its anatomy, behavior, and ecology, further enriching our understanding of this fascinating pterosaur. That's it for today's video. I hope you enjoyed it and found it informative. What's your favorite prehistoric apex predator? Share your thoughts in the comments below.